Hey guys, welcome back to chapter 16. I'm going to work one more salt example with you. I understand the difficulty of these problems. So what is the pH of a 0.25 molar solution of potassium acetate? Why don't you go ahead and pause the video and see how far you can get into this problem. All right, to solve this problem, the first thing we need to do is identify this as a salt. So potassium acetate is a salt. Break it apart into its ions. So we've got potassium and we've got acetate. Potassium is a +1 metal. It's also from group 1, so that's not going to have any effect on solution. It's going to be a neutral effect. Acetate is not one of the big five, so it's the anion of a weak acid. So using the AB, this is going to have a basic effect. It's going to act as a base. Right. So the next thing is to write an equation showing that this is going to be a basic effect. So CH2, H3O2 is going to react with water. This again is a base, so bases are proton acceptors. So this is going to be HC2H3O2. And water will act as an acid, donating a proton, and it'll be OH minus. Okay. Now we can write the equation for Kb. Again, this is a base, so it's Kb. We're going to have concentration of our products over concentration of our reactants. And then moving forward, in order to solve for the hydroxide concentration, we're going to need Kb and we're going to need an ice table. All right, so let me just rewrite this quickly and then we'll get into our ice table. All right, so if the molarity of the salt was 0.25, we can assume the molarity of acetate was also 0.25, and no mention of the other two, so those are 0 and 0. Only direction for the products to go is up, so that's going to be a plus X. Only direction for the reactant then to go is down is minus X. So 0.25 minus X, X, and X. So I've given you the value for Kb. And it's concentration of products, which is X, X, over concentration of reactants. And again, X is small, I'm going to assume. So we've got 0.56 times 10 to the negative 10 equals 0.25 X squared. Multiply by 0.25. So 5.56 times 10 to the negative 10 times 0.25 equals 1.39 times 10 to the negative 10. That's X squared. Then to get X by itself, we're going to take the square root. And we get X equals 1.18 times 10 to the negative 5th. Let me go ahead and validate this really quickly. So 1.18 times 10 to the negative fifth divided by 0.25 times 100 to make it a percentage. So again, this equals 0.005%. So well under that 5% mark. So certainly is valid. Okay. Again, what is X? X is the concentration of hydroxide at equilibrium. So that's what we're going to use to ultimately get to pH. So X equals 1.18 times 10 to the negative fifth. So that is the concentration of hydroxide. So POH is going to equal the negative log of that. So POH equals negative log 1.18 times 10 to the negative fifth. I'm going to get 4.93. And then pH equals 14 minus POH. So pH equals 9.07. All right, guys, that is it for chapter 16. There was a lot of information in this chapter. So I put together just kind of a list so you can quickly go over each of the topics, make sure that you're solid on them before you move to chapter 17. Again, in chapter 17, we're going to be utilizing many of the skills that we learned in 16. So this would be a great time to really stop and focus on practicing 16 material before you move forward into 17. Hope you guys found this helpful.